Hey guys, welcome back to my channel. So today in this video, we'll be discussing about an important OS concept of application scheduling process and the applications of scheduling process. So coming to my introduction, I'm a second year graduating student at SVC Bangalore. My name is Sai Nandan and I belong to Audi session. So contents that we're going to discuss today are what is scheduling process, importance of scheduling process, types of application scheduling, applications of scheduling in OS, CPU scheduling. So, what is your scheduling process? Scheduling, the process of organizing and prioritizing the execution of various applications or tasks in an efficient and an optimal manner. This is common in computing environments where multiple processors or applications need to run concurrently. Processing refers to the handling or execution of tasks and operations within an application or system. It involves allocation resources, managing execution time, and handling the output results. So here you can see a diagram of a simple process scheduling where the job queue there's a job queue and ready queue. Job queue which has this like a lot of processes, and these processes are transmitted to the ready queue, where this ready queue like transfers the processes to CPU, and CPU can only execute one process at a time. So the other process which performs like has something to do like an IO operation will do the IO operation and comes back to the ready queue. And if the CPU is free or in a free state, then the process in the ready queue will go to the CPU, or else it will run the IO stream or simply wait in the ready queue unless and until the CPU is free. So this is a simple process of scheduling in a CPU. Importance of scheduling process improves efficiency and performances of system, whether it is an operating system, task manager, or enterprise application. Ensures optimal resource utilization, CPU time, memory. Minimizes wait time and improves user experience by efficiently allocating memory resources, system management resources. Types of application scheduling. Preemptive scheduling involves interpreting running a task to allocate resources to higher priority tasks. Used in real-time operating systems, RTOS, and environments requiring quick responses. Excuse me. So, in primitive scheduling, higher priority tasks given more priority than lower priority tasks. So this is like more important in environments where quick responses are required. Example, time sharing systems, operating systems like Windows and Linux. We use primitive type of scheduling and non-primitive type of scheduling. The applications or tasks runs on completion without interruption, even if the higher priority tasks arise. Common in scenarios where interpreting the process could cause errors or data loss. Example, batch processing system, certain embedded systems. So in non-repeater type of system, it doesn't see the priority of the task. So even if the priority of the task is higher, it will not give the first priority to the higher priority task, but instead it will complete the process which is running now, and then it will go to the highest priority task. So these some of the examples of non-primitive type of scheduling are certain embedded systems and batch processing systems. A round robin scheduling, each task gets an equal slice of time in rotating manner, suitable for environments where tasks needs equal access to CPU time. Multi-user system like Linux. Priority scheduling assigns a priority level to tasks, with higher priority tasks being executed first. Can be primitive or non-primitive. Example, critical systems like medical equipment, software, network routers. So in priority scheduling, the higher priority task will be executed first and then followed by non higher priority task. So these can be like primitive or non-primitive. They are like using critical system like medical equipment, softwares, network routers, etc. And next we'll see about SJF or short job first. Prioritizes tasks based on their predicted execution time, with the shortest task executed first. Helps to reduce the waiting time of the task, but can result in longer. tasks being delayed indefinitely. Job scheduling and batch processing. So basically, SJF executes the shortest job. Like the execution time of that task is the shortest, it will be executed first and then it will be followed by the next process. So it sees the execution time and based on the execution time, the tasks are prioritized. So here you can see a diagram of, or a flowchart of a CPU scheduling process. First, it's like classified into two types, preemptive and non-preemptive. In preemptive, they are like subclassified into four types: priority scheduling, longest remaining job first, shortest remaining job first, round robin. Non-primitive are again classified into four types: shortest job first, longest job first, first come first serve, FCFS, and highest response ratio next. Applications of scheduling. Overview of process scheduling involves. Process scheduling refers to how an operating system decides which process applications to execute on the CPU at a given time. A process is a program in execution, and a scheduling manages the execution of process based on various algorithms. Key scheduling algorithm: first come first serve, FCFS. Simple but inefficient processes are executed in the order of their arrival. Shortest job next, SJN minimizes the average waiting time to be executed. The shorter process first. Priority scheduling. Each process has priority and the process with the highest priority is executed first. So key scheduling algorithms are classified into three types: FCFS, SJF, and priority scheduling. So FCFS is a first come first served basis. It is very inefficient as it has no priority based algorithm. So the processes are executed in the order of their arrival. So if the first process comes first, it doesn't see any priority, it will be executed and then it follows the next process. Shortest job first and shortest job next. It sees the execution time and which is having the lowest execution time will be executed first and then the remaining process will be followed in the same order. Priority scheduling: each process has a priority and these processes are executed in highest priority. So first it sees the highest priority and it completes that process and it follows the same algorithm. It sees the next highest priority and it will be executed and it follows on. Context switching refers to the process of saving state of currently running application and loading the state of the next one. Essential in primitive scheduling, ensuring the resources are allocated to the most appropriate application. CPU scheduling. Allocating CPU time to various running tasks based on the priority, time, slice, and other factors. Prevents a single process from monopolizing the CPU and ensure fair execution across the states. So here you can see scheduling criteria. So scheduling criteria helps in maximizing CPU utilization, throughput and minimizes in turnaround time, waiting time, and response time. So CPU has to have a continuous memory allocation cycles, so it cannot stop or be in a false state. So what happens here is CPU keeps the processes in a waiting state, and it has the following process scheduling algorithms. So it helps in very much maximizing the utilization of the CPU. Scheduling helps in maximizing the utilization of CPU and throughput of the CPU, and it minimizes the turnaround time, waiting time, and the response time of the CPU. So scheduling plays a very crucial role in CPU utilization. It plays an important role in response time and waiting time. Thanks for watching. If you like my video, consider subscribing my channel.